In this video, we will look at factorization. Just before we start, just a reminder on how to do mathematics. So number and copy the examples. Ask your tutor or teacher if there are any steps that you do not understand. Number the questions. And unless you have the ability to get fit while watching someone else run, you must do the questions on your own before watching the answers. Mark your answers. If it is incorrect, write down the corrections and make sure you understand where you went wrong. This will enable you to do better the next time you attempt a similar sum. So for an overview of what we will be doing in this video, first we're going to look at common factors, then difference of squares, then trinomials, and then we're going to look at how to identify which type it is and do a few mixed exercises. So for the first example, we have 5a plus 20. Now, this is just a common factor. So we basically just need to look at what common factor we have in each term. So if I have 5a plus 20, then I can see that 5 and 20 are multiples of 5. So that means I can take out 5. So everything I take out, I write here, and then I open my bracket. Now I see there's only an a on the one term. There's not an a on this term, so I can't take out an a. All I can take out is the 5. So now, once I have my bracket here, I need to determine what is left after I take out the 5. So if I take the 5 out, then what we have left here will be a. And if I take 5 out of 20, or I think about it as 20 divided by 5, then I have 4 left. So another way to look at it is whatever you take out, you have to just simply divide both with. So here we cancelled out and a was left, and there 20 goes into, or 5 goes into itself once and into 20 4 times. And then this is your final answer there. Now for example 1.2, I've got a, b plus a. So I can take out an a because I've got an a in both of these terms. So if I take out an a and open my brackets, if I take the a away in this first term, then a b is left. And now if I take a out of this term, that's like taking the entire term. Then I have to put a 1 as a placeholder, because remember, if I multiply the a back in, I want to end up again with the same that I have started with. So whenever you take out everything out of the term, then you have a 1 left. And once again, you can see that if you actually just divide all of these terms with a, this one's cancels, and then you have b left. And if this cancels, you have 1 over 1, which is just equal to 1. So example 1.3, I've got negative 8 x squared minus 8x. All right, now in this case we have an example of a negative. So if you have a negative in the first term, it's always better to take out the negative also. It's just neater for your final answer. So I take out a negative. That's the one thing I can take out. Next I look at my numbers, and then I'm going to look at my variables. So my numbers, I see I've got an 8 in both terms, so I can definitely take out 8 from both. And then I've got x squared and x. Now, I can take at most, I can take an x, because I need to take something that both of them can give me. So I can take out x because this term can only give me 1x. And then to open my bracket in this term, I have taken out the minus and the 8 and one of the x's. So all that's left in that term is just a x. And then when I take out a negative, I can just, whenever I take out a negative, to know what sign is left, I just change the sign. So if this sign is a negative, then it becomes a positive after I've taken out the negative. And then the 8 is gone, and I've taken out the x. So here we once again just have a 1 left. And you can test yourself by multiplying it back in and see if you get to the same answer again. Example 1.4. So here we have 12a squared b plus 16ab. All right, now 12 and 16, what is my highest common factor there? I know that these are both multiples of 4, and my highest common factor is 4, so I can take 4 out. Then a, so both of them contain a, and at most I can take 1 from each. So an A, and both have a B as well, so I take out a B, and then I open my bracket. So if you struggle to know what is left, you can maybe just write this is over 4AB, and then you say, okay, 4 goes into itself once and into 12 3 times, and then 1A cancels with 1 at the top, the B's will completely cancel, so what is left? We're left with 3A plus, and then do the same here. We know 16 divided by 4 is 4. I've taken out the A, I've taken out the B, so just the 4 is then left. So for example 1.5, we have 6x squared y squared z minus 3x squared plus 12x squared y z. All right. Now, between 6, 3, and 12, my highest common denominator is 3. So I take out 3. Then between x squared, all 3 of these terms actually contain an x squared. Oh, sorry, no, this one was an x to the power 3. So all of them can give me at most x to the power of 2. So that's the highest one I can take out there. And then I've got a y squared, and there's only, this term does not contain a y. So that means I can't take out a y at all. And then for the z, also the middle term also does not contain a z. So I cannot take out a z. So that's what I can take out at most from each of these terms. Now, if I take out that from this first term, 6 divided by 3 is 2. And then if I take out 2 of the x's, there's still 1 left. Y squared is left and z is left. And the next one, I've taken out everything. So then I just have a negative 1 left, plus 12 divided by 3 is 4. And then I took out the x squared, then y, z is left. And then example 1.6. All right, so now we have something different. We've got this plus or minus 3 with x plus 1. So now you need to recall how many terms are here. This is one term with the brackets, and this guy is another term. Now, if I look at what can I take out from each term, we can see that both contain these brackets. So you can actually take out the entire bracket as a highest common factor. So I'm going to say take out the entire bracket of x plus 1. Okay, and then we open our bracket for what is left. So in this term, we only have this 2x left, and in the second term, I've got the minus 3 left. So once again, if you take out x plus 1, then what is left is just this 2x minus this 3. Okay, so this is then where you pause the video and try these questions on your own, and then mark them or mark the question once you have tried it on your own. Okay, so for question 1.1, we've got 4a plus 8. So highest common factor there would be 4. And if I take out a 4, I'm left with a plus 2. Question 1.2, we've got 12ab minus 6a. So my highest common factor here is 6. And then if I take out, it's going to be 6. And then I can also take out a. Then it would be 6 divided by 12 is 2. And then b is left because the a has gone out, minus, and then I took out the 6 and the a, so there's only 1 as a placeholder left. Right, so for question 1.3, I've got 5x squared minus 10xy. Now, here my highest common factor between 5 and 10, that gives me 5. And there's an x at most in both that I can take out. So we have in the first term, we only have an x left because we took the 5 and one of the x's. And then here we have minus 2y. Since I took out a 5, 10 divided by 5 is 2, and then I took the x as well. Right, 1.4, ab squared minus a squared b squared c. Okay, now there's no coefficients, so let's start with a. So we can take at most one of the a's, because this guy only has one. Both have b squared, so I can take out a b squared because that's what both can give me. But this first term does not have a c, so I cannot take out a c. Alright, so if I take out a b squared, the first term, everybody goes out, so you have a placeholder of 1. And then a, from a squared, we only take out one a, so one a is left. We took out all of the b's, and then we have a c left as well. Okay, 1.5 minus ab plus ac. So once again, here we have a negative in the first term, so it would be good to take out a negative. And then also both terms contain an a, so we take out an a. So for the first term, because we took the negative out, we are left with a positive b. And for the second term, because it was a plus, it's now going to be a negative. And then the a was taken out, and we are left with a c. Question 1.6, minus 2x squared minus 4c to the power of 3. So once again, we can take out a negative. Then 2 and 4, highest common factor is 2. And then there's a x squared and a c to the power 3. So neither one, so for example, this one doesn't have an x to take out, and the first term doesn't have a c to take out. So therefore, we can't take out either. And then we can open our bracket. What is left if I take out a negative to here is just x squared. This minus then becomes a plus, and this will then be 4 divided by 2 is 2, and there's still that c to the power 3 that is left. Okay, 1.7. Now we have negative 2ab minus 4a minus 6b. All right, we can take out a negative. Then 2, 4, and 6, highest common factor is 2. Then we have an a for the first and the second terms, but not for the third, which means we don't take it out. B for everybody except for the second term, so that means we can't take it out. We open our bracket. If I take out negative 2 here, I'm left with AB. If I take out negative 2 from negative 4 divided, now this sign changes to a plus, and then 4 divided by 2 is 2a. If I take out a negative, it becomes a positive. 6 divided by 2 is 3, and then we have the b still there. Question 1.8. Now, in this case, we've got 4 terms. So v squared u minus 4u squared plus 2v u minus u. All right. Now, what do we see that is in each of these terms? We see that not all of them have coefficients, so we can't take out any numbers. Also, not all of them have a v, but we see that a u is in each of them. So I'm going to take out a u and open my brackets. So in this term, we only have v squared left minus 4, and then there's just a u left, one of them, because we took out 1, and then plus 2v minus 1, because this term only contains a u. And then this is our answer. Then for question 1.9, we've got 3x and then x plus 2 minus 5x plus 2. So both of these terms contain a bracket that says x plus 2, so I can take that out as my common factor, x plus 2, and then I open my brackets and I have 3x minus 5 left. Right, so those were the common factor questions. So for example 2.1. Now before we start with this example, I'd just like to go through the basic method of how we do these. Now difference of squares, always have two terms, right? And if we go to the very basic example is x squared minus y squared. So two terms, and then it has to be a negative. That's why it says difference of squares. And then both of these terms need to be perfect squares. That means that you can take the square root of that number. So for example, the square root of x will then be, so if I take the square root of x squared, that just gives me x. And also, the perfect squares are numbers that are, for example, 1, 4, 9, 16, 25, 36, because these are all perfect squares. So 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, and so on. So if you know these numbers off by heart, then it would also be much easier to identify them. So just to write these out as well, 4 squared and 5 squared. So if I see that I have two terms, both are perfect squares, and there's a negative in between them, then I know for sure this is difference of squares. And what I do is I open two brackets, and then I take the square root of the first term. So the square root of the first term is just x, and I write it here and here. And I put a plus here, or a minus and a plus. So one has to be plus, one has to be minus. It doesn't matter which order. And then the square root of the second term is y. So I write that over here and here. So this is a very basic example. Let's look at applying these same principles to the example 2.1. We've got 16x squared minus 25y squared. So we need to see if this is difference of squares. It will have two terms. It does. Does it have a negative? It does. And then are both of these terms perfect squares? We've got 16x squared. So 16 is a perfect squared or perfect square. And then whenever the exponent of a base is, or a variable is a even number like 2, 4, 6, 8, etc., then it also is a perfect square. So to open my two brackets, I've got one is a plus and one is a minus. And then what's the square root of 16x squared? So if I take the square root of 16x squared, then the square root of 16, here we see 16 is 4 squared, so the square root of 16 is 4. Square root of x we saw is, or x squared is just x, so square root of 16x squared is then 4x. So I write it over here and here. And then square root of 25y, so square root of 25 is 5, and then of y squared is y, so I write it over here and here, and that is then my answer. Now for example 2.2, once again I have two terms, I've got a negative in between them, and both of these are perfect squares, because if you take the square root of 1, you just get 1. Like for example 1 squared is 1. So now to do this one, I open two brackets, so let's just write it down, p squared minus 1. I open my two brackets, one is a plus, one is a minus. Square root of 9p squared is 3p. I write it over here and here, and then the square root of 1 is just 1. So I write it over there and there. And you can actually FOIL this out, and you will see that you will end up with the same answer. Example 2.3. All right, so now we have got 36a squared b squared minus 121c squared. And we've got two terms, we've got a negative in between them, and we have we've got that 36. These both these terms are perfect squares. So I open my two brackets, and I have a plus and a minus, and then the square root of 36 is 6, and then we've got the a and b. So that is, if I take the square root of 36a squared b squared, I will get 6ab. Right, so I write it over here as well. And then on this side, I've got 121c squared. So the square root of 121 is 11c. And then I just write it over here and here. Okay, so that's done. Question 2.1. So if we have p squared minus q squared, I just open my two brackets, and one is a plus, one is a minus. Square root of p, or p squared is just p, and then square root of q squared is q. And that's my answer. Question 2.2, a squared minus 4. So we have two terms, there's a negative in between them, and both of them are perfect squares. So if I have my two brackets, I have a plus and a minus. Square root of a squared is a, which I put here, and square root of 4 is 2. Question 2.3, I have two terms, so 16x squared minus 49, and I open my two brackets, so plus and minus. Square root of 16x squared will give me 4x, and the square root of 49 will be equal to 7. Question 2.4, we have 64x squared minus y squared z squared. So two terms with a negative in between them, and both of these terms are perfect squares. I've got two brackets over here, so one a plus, one a minus. Then this becomes 8x when I take the square root of that, and that's just yz over here and here. Okay, question 2.5. 81 a squared minus b squared c squared. So open your two brackets. One is a plus, one is a minus. Square root of 81a squared is 9a, which I write here and here. And b squared c squared is bc over here and here. Then question 2.6, a squared b squared minus 4. Two terms with a negative, and both are perfect squares. I've got two brackets, one a plus, one a minus. So square root of this term will give me ab, and the square root of this term will give me 2. Question 2.7, we have 25 minus 36 b squared. So opening my two brackets, I've got a plus and a minus. So 25 square root of 25 is 5, which comes here and here. Square root of 36b squared is 6b, which I write here and here. Question 2.8. Okay, so this one is a bit of a more of a challenging one. Now treat this, we see that this whole term over here, this is one term, right? And it's squared. So this is a perfect square because I can take the square root of that. I can say, what is the square root of 2x minus 3 all squared? Then this and this one just cancels each other out. Then you're just left with 2x minus 3. Okay, so just to copy this one, it says squared minus 9. So this is your one term that's a perfect square, and that's your other term that's a perfect square. So if we open brackets, but I'm just going to open these brackets like these. So then if this is my one term and I just take the square root of it, this is then the square root of that term. So I've still got my plus and my minus. So over here I write 2x minus 3, and over here 2x minus 3, and then over here I write the square root of 9, which is 3. Right, but now I can simplify this even further, because we have these two terms are both constant, they are like terms. So if I simplify this further, then I'm left with 2x minus 3 plus 3 is 0, so there's just 2x left in those brackets. And then here we've got 2x minus 3 minus another 3. So this is then 2x minus 6. So I can leave my answer like that, but even better is to, because this is just one term, the brackets aren't needed for this factor anymore, so you can just write it as 2x minus 6. Okay, now for this example. Now, this one goes on for a bit longer. Let's see what happens. If I take the square root of this, I've got my two brackets where one is a plus and one is a minus. Then the square root of a to the power 4, b to the power 4. So now remember that if you have, for example, x to the power of 8 and you take the square root of that, whenever you take the square root of a base, you just halve the exponent. So this would then become x to the power 4. Now, if we take the square root of a to the power 4, b to the power 4, we halve the exponent, which would give us then a squared, b squared. Now, writing that down, a squared, b squared, here and here. Then we have minus 1, so the square root of 1 is just 1. But now we can see we still have this. And that is, once again, this can be factorized even further because we have two terms with a negative and both of them are still perfect squares where you can take the square root. But this one over here, the first one, we can't actually factorize that because that has a plus and that would then not work for difference of squares. So the first one I'm just going to copy as a squared b squared plus 1. And then the second one I'm just going to once again open my two brackets and one with a plus, one with a minus. And now what's the square root of this a squared b squared is just ab over here and here. And then square root of 1 is just 1 over there and there. Now we have completely factorized this. Example 2.5. So here we have x to the power 4 minus 256. All right. So the square root of 256, we have 16. All right. So if we write that down, we've got our two brackets, and then we have, okay, this was 8, right? So taking the square root of x to the power of 8, we have x to the power of 4. Okay, so then we have our plus and minus, and then square root of 256 we saw was 16. So we have a 16 here and here. Now, once again, this one can be taken further, so I just copy this one over, x to the power 4 plus 16. Because that can't be factorized because of the plus, I open my two brackets and then I have square root of x to the power 4. So once again I halve my exponent, which gives me x squared, and 1 is a plus, 1 is a minus, and square root of 16 is 4 here and here. Once again I've got this one, and this is also two terms with both being perfect squares with a negative in between them. So I copy everything just as they are. So x to the power 4 plus 16, and then x squared plus 4. And then taking this one further, once again I open two brackets, one with a plus, one with a minus. Square root of x squared is x, and square root of 4 is 2, which I write there and there. And then example 2.6. Now in this case, we have 3x to the power 6 minus 75. So we do have two terms and there is a negative, but 3 and 75, these numbers aren't perfect squares. Now, once again, if you have, we need to look for, if we see that, or actually if we ask to factorize something, the first thing we always look for is a common factor. And 3 can go into itself and into 75. So let's first take out a 3 as a common factor. Then dividing that guy with 3 and that guy with 3, we are left with x to the power of 6 minus 25. And now what is left here is actually difference of squares. So here we'll have two brackets and one with a plus and minus. And this then, if I halve my exponent, will become x to the power 3, which is here and here. And then 25 is 5 squared. So square root of 25 will give me 5. Okay, and then we're done. Example 2.7. I've got 50 a squared b minus 2b, right? And I need to now see, we've got two terms with a negative, but 2b is not a perfect square. But we see that we can actually, both these numbers are even, so we can take out a 2. We can also take out a b. So if I do that, what is left? If I take out 2 from 50, or say 50 divided by 2, and then we get 25. And a squared is still there, but the b we took out, minus, so if I take the whole of the 2b out, there's just a 1 left. Then we have 2b. Now, here we have 2 terms, both are perfect squares. So we can now expand it into 2 brackets with a plus and a minus. And then we have 5a over here and here, and we've got 1 over here and here. Now for question 2.9. So I can see we have 5a squared minus 20. And here we see 5 or 20, neither of them are perfect squares, but also we first look for the common factors. So 5 and 20 are both multiples of 5, so I can take 5 out. Then I'm left with a squared minus 4. Now this is difference of squares because we've got 2 terms and both are perfect squares. So I'm going to say this is 5, and then I open my 2 brackets where one is a plus and one is a minus. And then the square root of a squared is just a, and the square root of 4 is 2 over here and there. Question 2.10. Here we have 16 x squared minus y squared. This one is pretty straightforward because we just have 2 terms, both being perfect squares. So we open our 2 brackets. We have plus, we have a minus. So 16x squared, the square root of that is just 4x. So here and here. And then y squared, we write over here and here, which is the square root of y squared. Question 2.11, I've got a to the power of 8 minus 1. So perfect squares, we open our 2 brackets with a plus and a minus, and then we have the square root of a to the power of 8, that gives us a to the power of 4, and we write that, and then square root of 1 is 1. Now this one is, as we can leave that as it is, but this guy we can take further because this is once again difference of squares. So I'm just going to copy this one over, and then over here we can expand it again into 2 brackets with a plus and a minus, where we have square root of a to the power of 4 is a squared plus 1 and a squared minus 1. All right, and then we have a squared minus 1, which we can take even further. So copying these guys, and then we expand this into 2 brackets where we have a plus 1 and a minus 1. Question 2.12, p to the power of 4 minus 81. Okay, so difference of squares, and in our 2 brackets we have a plus and a minus, and we have p squared plus square root of 81 is 9, and p squared minus 9. Then we can do nothing with p squared plus 9, but this p squared minus 9 we can again factorize, and that then becomes square root of p squared is p over here and here, and square root of 9 is 3, and then we are finished with that one. Okay, so that was difference of squares, and now we're going to move on to trinomials. So for the first example, I'm just going to go through the steps that you follow. We have this 12 over here. Now, first of all, in recognizing this, we have 3 terms. Trinomials are always 3 terms, and the first one has got x squared, the second one has just the x, and the third one is always a constant. So we're going to take this 12. So I say 12, and then we break this 12 up into its factors. Now, be careful, this is not its prime factors, it's just the factors, like saying 1 times what can give me 12, 1 times 12. 2 times what? That's 2 times 6. And 3 times 4. All right? And then I need to get plus 8. So let me just copy it over here. So we've got x squared plus 8x plus 12. Now, in order to get plus 8, I need to see which one of these can give me plus 8. So if I say 1 and 12, if I add the two, I get 13. If I subtract them, I get 11. So that can't give me plus 8. Let's try 2 and 6. If I say plus 2 plus 6, that will give me plus 8. So the two that I'm going to use are these two, whereas I'm going to write it as, so I just write two brackets, then my first terms in both of the brackets are always x, and then I simply write this. The plus 2 goes here, and this plus 6 goes over here. Okay, so just to recap, we took the 12 and we broke it up into its factors, and then we looked at the plus 8, and we decided which one of the factors, if we add them, which one can give us this second term's coefficient. So let's look at a following example. Now here we have x squared minus 7x plus 12. So once again, I'm going to take 12 and break it up into its factors. So I have 1 times 12. I have 2 times 6 and 3 times 4. All right, and I need to get negative 7. So adding these two, 11, subtracting, or is 13, subtracting them is 11. Adding these two is 8, subtracting them is 4. And then adding these two, 3 and 4 is 7. So this 2 will give me minus 7. But I'm not going to say plus 3 plus 4 because I want minus 7. So I'm going to say minus 3 minus 4 because that would equal minus 7. So if I have this, then to factorize it, we open two brackets, okay, and we always have an x over here and here, and then we have we write this minus 3, we just write it over here, and we write the minus 4 over there. Now what we can also do is to write x minus 4 and x minus 3. This is also correct. The order doesn't matter as long as the same sign goes with the same number. Right, now for 3.3, and once again we have 12. So breaking that up again is just 1 times 12 and 2 times 6 and 3 times 4. Now in this case, I need to get plus 1. If there's nothing there, that's a 1. So what can give me plus 1? Because the difference between these we saw was 11 and 4. But if I say, if I have 3 and 4, to get plus 1 from 3 and 4, I must say I plus 4 and I minus 3. That would give me plus 1. All right, so my answer there then would be to say x. So, well, you can start by opening your two brackets, always a x as your first term for both of them. And then this minus 3, I can say here, minus 3, and then plus 4, I put my plus 4 over there. Example 3.4. Once again, we have 12. So 1 times 12, 2 times 6, and 3 times 4. Now we need to get negative 4. So in order to get negative 4, I know the difference between 2 and 6 is negative 4. Now if you struggle with integers, you can just say, okay, what is, plus 2 plus 6 gives you plus 8. Minus 2 minus 6 gives you minus 8. Then we can say, okay, what is 6 plus 6 minus 2? That gives me plus 4. So minus 6 plus 2 will give me minus 4. So these ones are then the correct ones. And then I just open my two brackets and I have an x over here and an x over here. And then I have minus 6 and plus 2. So exactly as they are here, minus 6 and plus 2 go here and here. And like I mentioned before, you can also write it as x plus 2 and x minus 6. So the brackets can, the order of the brackets doesn't matter. Now for example 3.5, we've got 56. So first thing we need to do is we need to take the 56 and we need to write it or find its factors. So we start with a 1. We say 1 times 56, and then 2 times 28. We've got 3 can't go in there. 4 times, or let's just see on the calculator if we say 56 divided by 3 just to make sure. No. So then we say 56 divided by 4, we get 14. So 4 times 14. I know 5 can't go in because it doesn't end with a 5. And then we have 6. Let's try. I don't think 6 can go in there. So you say 56 divided by 6. No. And then I know that 7 can, because we have 7 times 8. So 7 times 8 also gives us 56. All right. So now we need to get minus 1. So if there's nothing there, there's 1 as a coefficient. So we see that 1 and 56 are too far apart. 2 and 28, 4 and 14 can give me either 10 or 18. But 7 and 8, if I want minus 1, I have to say plus 7 minus 8 to get negative 1. So then I can write my answer as 2 brackets where both start with an x, and it will be plus 7 and minus 8 as I just copy these numbers into my brackets. Right, so once again we have 56. So its factors, as we saw, were 1 times 56 was 2 times 28, 4 times 14, and it was 7 times 8. All right, so to get this time, we need to get negative 15. So once again, 1 and 56 too far apart. 2 and 28 can either, if I add them, I get 30. If I subtract them, I get 26. These two, if I add, I get 18. If I subtract, I get 10. 7 and 8, if I add them, I actually get 15. But I want negative 15, not positive 15. So instead of saying, plus 7 plus 8, I'm going to say minus 7 minus 8. That will give me negative 15. So I've got my 2 brackets, and then I have x here and here. So I have minus 7 and x minus 8. Okay, so question 3.1. We need to start off with the 3 and list its factors. So I have 1 times 3, and that's basically all factors there are. So I need to get plus 4. To get plus 4, I'm going to say plus 1 plus 3. So my 2 brackets are then going to be x plus 1 and x plus 3. In this case, we've got minus 2. So we list 2's factors. We don't have to worry about the negative for now. We have 2, and we write 1 times 2, and that's all factors there are. We need to get plus 1. To get plus 1, I'm going to say plus 2 minus 1. This will equal plus 1. So now I have my 2 brackets, and one is x plus 1 and x plus 2 and x minus 1. Also notice if this sign is negative, that means that the 2 signs in your brackets must be opposite. If this sign is a plus, then the 2 signs in the brackets need to be the same. They can be both negative or they can be both positive. And that's what this negative, that's a good way to check that your signs are correct. Okay, so here we have our constant as 20. So I'm going to write 20, and then I'm going to say 1 times 20, and we've got 2 times 10. We've got 3 can't go in there. 4 times by 5. And I think that's all the factors that there are. We need to get negative 9. Now 1 and 20 can either give me 19 or 21. 2 and 10 can either give me 8 or 12. 4 and 5 gives me 1 and 9. So I'm looking for 9. So in order to get a negative 9, I'm going to say minus 4, minus 5. So these will then give me x minus 4, x minus 5. Okay, constant is 3. We know the factors for 3 is just 1 times 3. And I need to get negative 4. So to get negative 4, I'm just going to say minus 1 minus 3. So this is then going to be x minus 1 and x minus 3. Okay, we have 10 as our constant. So we have 1 times 10 and we have 2 times 5. And I need to get negative 11. So 1 and 10 can either give me 9 or 11. So this is the ones we're going to go with. And to get negative 11, I must say I subtract 1 and I subtract another 10. And this will then give me minus 11. So therefore I have x minus 1 and x minus 10. Okay, now we have 2. And 2 is simple, that's just 1 times 2. And to get plus 3, I'm going to say add 1, add another 2, so then you get a total of 3. So we have x plus 1 and x plus 2. Now we have 10. So we once again list the factors of 10. We've got 1 times 10, 2 times 5, and we want 3. So 1 and 10 we saw was 11 and 9. 2 and 5, if I add them I get 7, if I subtract them I get 3. So to get plus 3 I must say plus 5 minus 2. Alright, so here we'll have then x minus 2 and x plus 5. Question 3.8. Factors of 8 are 1 times 8, 2 times 4, and we need 9. So 1 and 8, if I add them, I get 9. So I'm going to say plus 1 plus 8, and this will then give me x plus 1 and x plus 8. Then for question 3.9, for 14, the constant, it's 1 times 14, 2 times 7, and I believe that's all the factors. Alright, I need plus 9. If I add these two, I get 15. If I subtract them, I get 13. If I add these two, I get 9. So that's basically what I want. So I'm going to add them. I'm going to say plus 2 plus 7. So here we have x plus 2 and x plus 7. Okay, so here we have x squared plus 5x plus 4. We want the factors of 4, so that's 1 times 4 and 2 times 2. I need plus 5, so adding 1 and 4 gives me 5, so I can say plus 1 plus 4. So we simply write x plus 1 and x plus 4. Okay, for 3.11, I need the factors of 9. So it's going to be 1 times 9, 2 can't go in, 3 times 3. And to get negative 6, I'm going to say, well, if I add these two, I get 10. If I subtract them, I get 8. Adding these two gives me 6, but I don't want plus 6, I want minus 6. So I'm going to say minus 3 and minus another 3, which would then equal to minus 6. So this is then going to be x minus 3 and x minus 3. Okay, now to move on to some other examples of trinomials. Over here we see we've got 2x squared minus 14x minus 16. Now this looks like it's in the form, and it is a trinomial, but we see that this is a coefficient. Now in grade 9 you're only going to do trinomials without any coefficients. In grade 10 we start with trinomials with coefficients, but in grade 9 if you see a coefficient here, you have to first take out a common factor. So if I first take out the 2 as a common factor, then for the first term I've got left x squared. The next one becomes minus 7x, and then finally, the 16 divided by 2 gives me minus 8. So now I can take my factors of 8, which is 1 times 8 and 2 times 4. Now to get negative 7, if I add 1 and 8, I get plus 7. So I'm going to say minus 1 minus another 8, and that gives me minus 7. So now I still, in the next step, write my 2, but then I just factorize my trinomial with its 2 brackets, where I've got x in each of them, and this is then minus 1 minus 8. Okay, now in this example, we anyway always have to look for a common factor first. And here we can see that all of these terms contain a and b. So we're definitely going to take out a and b. And also the first term is a negative. Now if you have like we saw in common factor, if the first term is a negative, it's good to take out a negative. So I'm going to take out a negative. And then I'm going to determine how much of how many a's can I take out. Now the first term have 1, the second term and the third, so all 3 of them have 1a, which means I can only take out 1a. And then to move on to b, we've got b squared, so all of them also have a b squared, so we're going to take out a b squared. Then for x, we've got an x squared, an x, and no x. So that means x can't go out because the third term contains no x's. So I'm going to open my bracket. Now if I take out this minus b, if I took out the minus, took out the a and the b, so I took out all of this, which means we're left with x squared. And then I took this part out, but be careful, because we took out a negative, this sign in front of this term needs to change. So this becomes minus. Taking this out, we're left with the 8 and with the x there. So this is 8x. And then from the third term, we're going to change the sign because we took out a negative. And then we took this ab squared out, which means we're left with the 20, so minus 20. Now we see that these are 3 terms where we've got x squared, an x, and a constant. So we can apply trinomial factorization. So I've got this common factor that I took out still, and I've got my 2 brackets. Now factors of 20 is 1 times 20 and 2 times 10 and 4 times 5. So I want to get negative 8. Now these two together, 21 or 19, these two is 12 or 8, and I am looking for 8. Now to get negative 8, I must say minus 8 and plus 2. If you that would give me negative 8. So I'm going to say x plus 2 and x minus 10. Okay, so question 3.2, we see that we have 3.12, we see that we have a 2 over here, which we first need to factorize out. So if I take that 2 out, I'm left with, for the first time, I'm left with x squared. If I divide 8 by 2, I'm left with 4, so that becomes minus 4x. If I divide 8 by 2, once again 4, so plus 4. Right, now we've got an x squared, an x, and a constant. So we start with a 4 where we list its factors. We've got 1 times 4 and 2 times 2. Now I need to get negative 4. And if I take 2 and 2, then if I add them I get 4, but if I want minus 4, so I'm going to say minus 2 minus another 2. So my answer then is going to be x minus 2, x minus 2. Okay, now we have this. Now, see, we can take out a common factor of 4. We saw now in a previous example that 4 times 14 gives me 56. So taking out a 4, we have x squared. And then 36 divided by 4 is 9. So minus 9x. And then plus 14. So the constant is 14, which means I'm going to list my factors for 14 as 1 times 14, 2 times 7. I think those are the factors. I need to get negative 9. 1 and 14 gives me 15 or 13. 2 and 7 gives me 5 or 9. So to get negative 9, I must say minus 2 minus 7. And that gives me negative 9. So this is going to be equal to 4 with its two brackets, where the one is x minus 2 and the other one is x minus 7. Then for 3.14, so over here we have a common factor of a, which we first need to take out. So if I take out the a, then a is taken out, x squared is left. Then a goes out, and minus 5x is left. And then once again a goes out and minus 6 is left. So we are left with a trinomial, and so we know it goes into two brackets with the x here and here. So my factors for the constant is 6, or factors of 6 is 1 times 6 and 2 times 3. Now to get negative 5, I can actually say, I can say minus 5 plus 1, or I can say minus 2 minus 3. Now, which one will be the correct one? Remember what I said, when we look at this sign, this negative over here tells you the signs need to be opposite. They need to be different. If this was a plus, we'd go with the same sign. So these ones have opposite signs, which means we're going to go with plus 1 minus 6. If this was a plus, we'd write minus 2 and minus 3. Okay, once again we have a common factor. We see there's quite a lot of x's that we can take out, and we can take out a negative. So if I take out a negative, I can also take out at most x to the power 3, because all of them contain at least x to the power 3. So I take out x to the power 3, and then we have, if I take out a negative, this becomes a positive. If I take 3 of these x's out, I'm left with 2 of them. So this is then going to be x to the power of 2. And then this sign needs to change. So remember to change all the signs when you take out a negative. Then we still have that 11 there. And then if I take away 3 of these x's, then there's still 1 x that remains. And all 3 of these were taken out. So we have plus 12 that remains. So then this becomes minus x to the power 3. Now this is a trinomial. So we have our two brackets with the x here and here. So factors of 12 is 1 times 12, 2 times 6, and 3 times 4. All right. And to get plus 11, 1 and 12 can give me either 13 or 11. And that means I can go and say plus 12 minus 1, because that would give me plus 11. So this is minus 1 plus 12. Okay, in this one, we can actually take out a coefficient of 2, and we can take out a squared at most. So if I take out 2 and a squared, in the first term, I've taken out 2, and I've taken out 2 of these. So all that's left is going to be a squared. So just make sure it's the same when you multiply them back. Then you know you factorized it correctly. Minus 8 divided by 2 is 4. And taking out 2 of these a's, then you're left with 1. And then taking out a 2 there, we're left with plus 4. And you've taken out all of the a's because you've taken out a squared. All right, so now 4 has got, 4 is 1 times 4, 2 times 2. All right, I need to get negative 4. And that means I'm going to say minus 2 minus 2. So I'm going to write 2a squared. And then in brackets, I write a minus 2, a minus 2. And that was trinomials. So now let's look at some mixed exercises. So before we get started with practical sums, when you're writing an examination, they basically just tell you to factorize. They don't tell you what type it is. So you need to be able to distinguish between just taking out a common factor or difference of squares or trinomial. So few simple steps to follow. The first thing you do is to always look for a common factor. That's the very first thing that you always do when you have to factorize an expression. Now, then after you look for a common factor, you could have taken out a common factor and then the sum could be complete, or you can take out a common factor and then you have to take it further to be either a trinomial or difference of squares. So there are those two possibilities. Now, after you have either taken out a common factor or not, then you can see, then you can determine between the two that's remaining is the difference of squares and the trinomial factorization. So, and those are easily distinguished because if you have two terms, then it will always be difference of squares. And we've seen what it looks like with the difference of squares. Now, if you have two terms, now you can decide is a difference of squares or not. Because with difference of squares, you have to have a negative between your two terms. And both of these terms need to be perfect squares. Then you know, okay, this is difference of squares, and you can then apply those methods. Next, if you have three terms, then it would most likely be trinomial factorization. And you also know what that looks like. The first term will always have the variable squared, second just the variable, and then the third one is a constant. All right, so let's look at a few practical examples. We've got example 4.1, and first step was, let's see if there's a common factor. So I can see that 4, 12, and 16 are all multiples of 4, so there's definitely a common factor of 4, and also all three terms contain x. So I can take out 4x as a common factor. Then if I take it out, now this is the other way where we just say, okay, if I take out 4x, I just divide each and every term with whatever I take out. So the 4's will cancel, and then this x cancels with 1 at the top, which means we have x squared left. So I open my bracket. So for the first term, what is left is just x squared. And then moving on to the next term, we have a negative there. And 4 goes into itself once, into 12 3 times. This x and that x cancels. So we're left with 3x. Because there's two x's and there's 1 at the bottom. Then for the final term, we've got a negative. 4 goes into itself once and into 16 4 times. These two x's cancel, so we are left with 4. All right, now can we go further? Can we do something with this? We see there's three terms, so it's possibly trinomial. And then to determine whether it is, we see that this is x squared, x, and a constant. So yes, let's see if we can factorize that. And I know trinomial needs to go into two terms, whereas the x is our first term in both of these brackets. All right, so we take 4 and we write its factors 1 times 4 and 2 times 2. To get negative 3, I can say plus 1 and minus 4. So x plus 1, x minus 4. And then that is my final factorized form. Okay, so for this one, I have two terms, but also remember, first thing we needed to check is to see if we have a common factor. So in this term we have a plus b, and also in this term we also have an a plus b. So that's going to be our common factor, is to take out those two brackets, or take out a plus b as our common factor. So we write that down, then we open a bracket for what is left. So in this term we have an m left, and in this term we just have an n left, so it becomes plus n, and that is then our final answer there. Okay, now for the third example, here we have two terms, and first thing, do we have a common factor? So 4 can't go into 25, that means we can't take out a 4, so there is no common factor. Now let's look at step 2. How many terms are there? So since there are two terms, we know we need to apply difference of squares. So we have that both terms are perfect squares. So in doing this, we just say we open two brackets, and we know for difference of squares, one must be a plus and one must be a minus. And then what is the square root of 4a squared? The square root of 4a squared is just 2a. So then I write 2a over here and over here, and then the square root of 25 is just 5. So I write 5 over here and over there. Question 4.1. First thing, look for a common factor. So there's a 2 in both of these terms. So I take out 2, which leaves me with x to the power 4 minus 1. Now, is this all I can do, or can I take this further? We have 2 terms, so possibly difference of squares, and both are perfect squares with a negative. So yes, I take it further and I write my 2 brackets where I have square root of x to the power 4 is x squared. So then with a plus and a minus, and then 1 is my square root of 1. Now even further, this that is left here is also a difference of squares. 2 terms and both are perfect squares. So therefore I just write down or carry down on to the next step everything that is in that line. I carry down and then I just expand this further. So this is then x plus 1 and x minus 1. Okay, in this one, first step, is there a common factor? So we see there's an x in the first 2 terms but not in the third, and we don't have any numbers that we can take out. So now, second step, how many terms are there? Now we see that there's 3 terms, and we see that the first one is squared, then an x, and then a constant. So we know that this then is trinomial, which means we start off by finding the factors of 15, which is 1 times 15, 3 times 5, and I think that is all the factors that we have there. And we need to find plus 2. So to get plus 2, I can say plus 5 and minus 3. So to factorize that, that is simply going to be 2 brackets where as we have x, and then minus 3, and then plus 5. Okay, first of all, common factor, we see there's an a in each of these terms, so I can take out an a. If I take out a, for the first term, if I take out the a, what is left is that x squared, and then if I take out this a, I'm left with the minus 5x, and then taking out this a, I'm left with plus 6. Alright, so now we see we have 3 terms, and this is then the standard form of a trinomial, which means we can apply trinomial factorization. So we have 6 where we have its factors as 1 times 6 and 2 times 3. Now I need to get negative 5, and in order to get negative 5, I can say plus 1 minus 6, that gives me negative 5, and also minus 2 minus 3. Now which one am I going to use? I use this sign to determine that, and this sign, because this sign is positive, I know with my 2 brackets that the signs need to be the same. And if they are the same, you can just look at this sign, that's going to be the sign it will be. But we can start off by saying we've got an x in both of these brackets, and we are going to use this one because both of these signs are negative, so we have minus 2 and minus 3. Okay, question 4.4. So here we have 2 terms, common factor. We have no common factor because there's a 1. So because it's 2 terms, it's most likely difference of squares, and we see that both of them are perfect squares. So difference of squares, we know there's 2 brackets, whereas one is a plus, one is a minus. And what is the square root of that is 4x, which I write here and here. What is the square root of 1? It's just 1, which I write there and there. Okay, 4.5. So first step, common factor. We have a 3, which also can go into 27. So I know that 3 can come out. And also there's a in both of these terms, and at most there's actually a squared in both. So I can take out an a squared, which comes out. So open my bracket. Now if I take out 3 and a squared, then I'm only left with 1a. And for the next one, if I take out 3a squared, then I am left with 27 divided by 3, which is 9. Okay, now can I take this further? This is a 9, that's a. this looks like two terms, difference of squares, and this term here, the second term, is a perfect square, but a is not. If it was a squared, I could have taken it further, but because this is just a, that is where the sum ends. Okay, question 4.6. All right, now in this case, we have these two terms, whereas this is one term and that is one term. So to look for a common factor, we see that both terms contain this a minus b. So I can take a minus b out as a whole bracket, open my brackets for what is left, and we have p squared plus q squared. So p squared plus q squared. Now, from what is left, can I go further? We know it's two terms, so it must be difference of squares. And yes, both are perfect squares, but there's one problem. This is a plus, which means that we cannot apply difference of squares because it needs to be a minus. So this is then our final answer. Okay, now we have the following, and this one is actually, it's actually called grouping, which you will do more of in grade 10, but we'll just look at the general method of doing it. It is actually like the previous one, where we have two brackets that we take out, and now we're just going to take out, because we've got a common factor in this first two terms, and we have a common factor in these two terms. So what I'm going to do is, and this is normally where four terms come in. So you know, two terms are difference of squares, three terms are trinomial, and four terms are grouping. And with grouping, we take out the common factor from the first two terms, and that's x, where we have y minus 4, y plus 4 that is left, and then we take out minus r. So if I take out a negative r, I'm left with 4 plus y. All right, so taking out the common factor from the first two and then from the second two. But now we see that we have two terms here, and in this bracket we've got y plus 4 and this one 4 plus y. We can actually just change these two around, so then we end up with y plus 4, because we've 4 plus y is the same as y plus 4. So I'm going to take out this then as my common factor, y plus 4, and then x minus r. Okay, 4.8, first step, common factor. Now I have a negative because the first term is a negative. And then also from both of these, I can see that 4 and 12, 4 can go into both of these. Both contain A's and B's. So we're going to take out a negative. We're going to take out a 4. And we're going to take out 1A at most. And we can also take out B to the power 3 at most. So B to the power 3 comes out. Now, opening the bracket, we look at the first term. What is left if I take out the negative? Divide 12 by 4 gives me 3, and then I've got 1a has gone out, so I'm just left with an a, and there is b to the power 3 has gone out, so there's 1b left there. And then if I took out a negative from the second term, the sign must change, and then the 4 went out, the a went out, and the b to the power 3 went out, so that means we're just left with a constant, a 1. And that is then our final answer, because we have two terms and it's a negative, but this is the 3ab is not a perfect square. Question 4.9. Over here, common factor. So 2 and 8, 2 can go into both, so I'm going to take out a 2. In the first term, I'm left with 1, and then in the second term, if I say 8 divided by 2 is 4, so that's 4y squared. Now, can we go further? We've got two terms with a negative and both are perfect squares. So yes, we can apply difference of squares. So I've got 2, whereas I've got two brackets, one with a plus, one with a minus. Square root of that goes here and here. Square root of 4y squared goes here, 2y and 2y. y. Okay, question 4.10. Now, is there a common factor? There's not a common factor because there's not x over here and there's no coefficient over here. So do we have 2 or 3 terms? We've got 3 terms, which means we can possibly have a trinomial. And we've got an x squared, an x, and a constant. So yes, it is a trinomial. So we start off by taking the factors of 16. And we have 1 times 16, 2 times 8, and 4 times 4. Okay, and we need to get plus 8. So in order to get plus 8, these two together gives me 17 or 15, and then these two gives me either 10 or 6, and then 4 can give me 0 or 8. So to get plus 8 is when I add 4 to 4. So my answer then will be x plus 4, x plus 4. Question 4.11. We start off with common factor. We see that we have 3, 6, and 45, which are all multiples of 3. So I can take out a 3. And then if I take out 3, I'm left with x squared plus, so this becomes 2x minus, so 45 divided by 3 is 15, so minus 15. Okay, so can we go further? This is 3 terms. We've got x squared, x, and a constant. So yes, this is trinomial. And taking 15's factors, that's 1 times 15 and 3 times 5. So to get plus 2, I'm going to say plus 5 minus 3. So this is going to be x plus 5 and x minus 3. Right, so that was the mixed questions, and that means we are finished with this video.